dehydration and hydrolysis. 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 If you look at that, the word lysis means to split. And hydro is water, so this means like splitting with water. And dehydration means to dry up. It means to take water away. Got that? Okay. So we're going to see what happens. These two reactions are very important in biology. And they have to do with functional groups. So what we're going to do is we're going to take a molecule, but it doesn't matter what it is. Your textbook uses big hexagon-shaped molecules, but those are maybe too big for us to worry about. So let's take a molecule that has this. We'll just draw it nice and simple. Well, maybe we can draw. And let's say there's an OH here on this end. And there's another molecule over here. And I'm going to draw it sort of backwards. The OH happens to be on this end. We'll make it a smaller one so we can save time. Let's say these two molecules come together. Well, when they come close together, these two functional groups can interact with each other. And when they interact, you'll notice something. You'll notice that there's O's and H's there. And what molecule is made of H's and O's? Well, what molecule? Common molecule? Water, H2O. So what would happen here is, what if this pops off, and this H pops off, then what you get is an H2O, which would pop off, essentially. Two H's and an O. And then the result would be a molecule that is linked together by an O. There's the O. It's the red O. Maybe I'll put it in red so we know where it came from. Now here's the trick. How do you know if it's the red O and then the H2O is the red H and the two black ones? Or if it's the black H and the red O and it's the black O that's left over? You really don't, right? As long as one of the O's hangs around and another O goes off with the two H's, this works. So I could have drawn my green box around the two red OH and just the black H as well. It doesn't really matter which one, right? But I've drawn it this way, so I'll continue to draw it like this. And guess what it produces? What would you call that molecule from before? It's got an O in the middle. Ether. An ether, right. Now, this reaction has a name. Because we took water away, we dehydrated this group of molecules. We sucked water out of it. So we call it a dehydration reaction. It's very common, and it's a common way to link molecules together. A dehydration reaction. And the reason is because we took a water out. There's another word for this that when I was your age, we learned this as a condensation reaction. To condensate, or to condense, I guess is the real word. Condensate is not a word, I don't think. To condense also means, when you think about water in the air as vapor, and if the window's really cold, the water will condense on it, right? And it'll form a drop of dew on the window. Well, that's taking water out of the air. So condensing is another way of saying taking water away. So when I was condensation, when I was a kid, we learned it as a condensation reaction. So those two words mean the same thing, essentially. Taking the water out, and what's left joins together, and it usually produces an ether. Produces an ether. Or what we might, I learned it to be called an ether linkage, joining of two things linked together by an O, so that we call it an ether linkage. Okay? All right. Now, of course, you can also, your textbook doesn't really talk about, doesn't give you any pictures for the opposite. But if the opposite of this were to happen, if you were to add water to something, you could use the water to split it apart. So the reverse, the exact reverse of this would be this. We'll start with our molecule that has the ether linkage in it, right there. That's the final product. And this time, instead of taking water away, we will take a water molecule. Oops, that was supposed to be red. It's not listening. Red. We take a water molecule and we add it in. So in other words, as water is floating around, remember these things are held together by attractions, plus and minus. So they're not solid tied with iron bars. And so if something else comes by and puts a little pressure on it by pushing and pulling with its electrons, it could cause this to kind of shake apart. And this H2O might shake apart, and in the jumble, things will go back. So the H and the two, so what will happen essentially is the H will come off, and the OH, the old water dance, will happen, right? Because we know that it's easy for water to turn into this. I should have put little arrows there. And then, on this side, see, the H can go back with the O, and then we get a broken apart molecule, and over here we get the OH going that way and going back to there. So it's the opposite. You'll notice this picture that I've drawn here is exactly the same as what we started with in the other one, right? We went backwards. So this is using water to split things. So it's called hydrolysis. Hydrolysis, water splitting. And it's just the opposite. So this kind of reaction is extremely common. It's going to happen all the time in our biochemistry that we're going to learn. It's called a condensation or a dehydration reaction when the water is taken away and you join. And it's called a hydrolysis when the water goes back in and is apart. And of course, in the water, this can happen all the time because of the water dance. That water is tugging and pulling, so things are like, oh, I'm together, but then it's like, oh, I'm going to go with you. And it's continuously dancing around, pulling and pushing, and causing these joins and splits to happen. Okay? So that's what we call dehydration, and the opposite is the hydrolysis reaction.